Hi, friends, and welcome to the Data Platform Summit of 2020. This is a virtual recording of optimizing query performance in Azure SQL Database. I'm your host today, John Morehouse. I'm a consultant with Denny Associates. My contact information is on the slide before you. Feel free to drop me an email if you wish about any questions you might have about the presentation, or even if you're having SQL Server questions or issues at work or wherever you might be having issues. I'm always happy to try to help get them solved. If I don't know the answer, I probably can point you in the right direction. My LinkedIn information is also on the slide. Feel free to connect with me on LinkedIn if you so wish to do so. I am an avid tweeter. Twitter is probably the only social media outlet that I use on a regular basis, so feel free to connect with me on Twitter. I am SQL R Us, and I have to quantify that. It's like Toys R Us, everything toys. I am SQL R Us. I touch just about every facet of SQL Server, short of actually building Power BI reports or cubes or doing data warehousing. I can support the infrastructure underneath the scenes, but don't ask me to build a report. That's not my forte. I do blog at sqlrus.com. I am that DBA that likes to reverse engineer hexadecimal at 10:30 on a Saturday night. So I usually blog about the internals of SQL Server, how things kind of work, encryption, compression, DevOps, sometimes continuous delivery. So more about the internal workings of SQL Server. I do blog about PowerShell and automation because I like to make things easy. But feel free to read my blog if you want. I do speak quite often at conferences all over the place. Nowadays, it's mostly virtual because of the current state of affairs. I am a member of the MVP Data Platform program from Microsoft. I'm extremely honored to be a part of that program. I'm also a VMV expert for 2020. It's not listed on the slide before you, but I also help run the local user group, and I'm based out of Louisville, Kentucky in the United States, and I help organize SQL Saturdays. So I am pretty heavily involved in the SQL Server community. I work for a company called Denny Associates. Just a quick blurb about what we do. We're a small boutique of SQL Server professionals. We like to make SQL Server run better for you. So if you are having problems at work and are looking for a SQL Server consultant, we would love to at least talk to you. So feel free to drop us a line. A quick agenda that we're going to talk about today. We're going to talk about how to find bad queries in Azure SQL Database. We've got a couple options available to us, so we're going to go through a couple of them just so we can see how they work. We're going to talk about service tiers and how choosing the correct service tier or changing service tiers could either help or hurt your performance depending on what your workloads are doing. We're going to take a look at doing automatic tuning within Azure SQL Database. We actually have the option to do some automatic tuning for us and do the magic for us so we don't have to worry about it. And then we're going to talk about some of the 2019 SQL Server 2019 enhancements that came out that can also help your performance in Azure SQL Database. And then finally, I've got some demonstrations of a couple of things that we'll talk about throughout the presentation. And so hopefully you can see a real world example of how things will work and how you can improve your performance in Azure SQL Database. So one of the questions I do get on occasion is, where do we find performance issues in Azure SQL Database? Thankfully, and if you think about the Azure SQL products in general, all of them, SQL Server on an Azure virtual machine, Azure SQL Database, Azure SQL Managed Instance, it still is just SQL underneath the hood. It's just kind of packaged a little bit differently to the consumers, the end users, in terms of how it functions. But it's still SQL underneath the hood. We just have to find ways to find performance issues in a different manner, especially when we work with things like Azure SQL Database. The information's there, we just got to find it. So one of the first places that I always recommend that people go is Query Performance Insights. This is a default metrics gathering tool that is located directly within the portal. So it's available for every single Azure SQL database that you create. So as soon as I stand up a new Azure SQL database, I'll have access to the Query Performance Insights that is provided to me from the portal. Now you can see on the screen before you that we actually get some pretty good, decent information at a higher level as to how things might be performing. We can see the top queries by CPU, data I/O or log I/O, so we can see how much traffic and how much data my database might be moving back and forth. We can identify long-running queries. We can actually do some custom analytics on our database to help pinpoint where performance issues might lie. It really gives us some quick analytics to identify those performance issues, and then we can move forward with maybe other avenues to address those performance issues. It is based on Query Store. So by default with Azure SQL Database, we do get Query Store enabled automatically when we create a new database. So I wouldn't recommend turning it off or anything like that. So make sure that we leave Query Store alone, and so we can feed the information from Query Store into the Query Performance Insights. One of the other beneficial factors of Query Performance Insights is that it'll actually give us some recommendations based off of our individual workloads. So as our workloads are going through the database, the Query Performance Insights in conjunction with Query Store can give us recommendations on maybe we need indexing, maybe we need to drop an index, some other various things that we could do to help improve our performance. With Query Performance Insights, I mentioned that it's based off Query Store. So not only can we use Query Performance Insights to see that information, we can actually go directly to Query Store within SQL Server Management Studio, or SSMS, and help to identify performance issues with our queries in Azure SQL Database. We can see from the diagram or the picture on the slide, we've actually got a couple of options and how we can actually determine where our performance issues lie. The first one I always go to is the top resource consuming queries, which is that third one from the top of the list. That will give me a quick overview as to what resources or which queries are consuming the most resources for my SQL Server. Another great option about Query Store is that we can actually find plan regression. You'll notice the very top option, regressed queries. I can use that view within Query Store to see what query plans have regressed over time, and they are now underperforming based off the available machine learning and analytics that happens behind the scenes in SQL Server to identify those queries. So now we have an easy way that's graphical within a user interface to identify queries that are performing poorly and or queries that have slowly progressed worse in performance with a regression. We also get a very large amount of query metrics when we're looking at Query Store. So we can see a number of things versus duration or CPU or I/O. We can see a number of things within Query Store to help facilitate finding those performance issues. It's really comprised of 3 different stores, which are plan, runtime, and wait stats. So those 3 stores together, we get a nice view. You'll also notice that we can get some wait statistics on our queries, so we can help further identify what the problem might be with our performance. And thankfully with Query Store, it is persisted. So even if the Azure SQL Database is scaled or it's failed over in a auto failover group or geo-replication, that information is still accessible even after failure. We do have DMVs available to us within SQL Server Management Studio in the database. So we can actually do some custom querying of those DMVs if we so desire. So Query Store is a great way and a great location to do some analytics on our Azure SQL Database query performance and gives us a way to help get those problems fixed. This is what Query Store kind of looks like from a user interface perspective if you have never seen it. In the demos, we'll go take a look at Query Store just so you can see how to find it. I've got an Azure SQL database stood up and we'll go play around with that database. I'll actually run a workload against it and we'll see what Query Store might tell us about our performance. And so you can see it. You can see it's a very graphical interface. We got a lot of metrics in there. You can see in the drop down above, duration, CPU time, logical reads, logical writes. We get the execution plan below so we can see what the execution plan looks like. And then we can make educated decisions on how we want to fix that performance once we can get that information. Another great tool that is coming out is Log Analytics for SQL Database. One thing to note that right now at the time of this presentation, it is not GA, meaning it is not generally available. It is in a public preview, so you can sign up for it. It is not enabled by default. Because it's a public preview still, you have to opt in for it. I suspect that it will become public GA or generally available at some point in time in the near future. I have no information about that whatsoever. So just, if you want to look at this, you certainly can. and you can add it to your individual databases. It is configured on a per database level, so you have to go into each database and at least configure it. You can actually take the log analytics, and you can see in the log on the right-hand side, it actually offers up quite a bit of information about our Azure SQL database. And we can send it to 3 different destinations. We can send it to a log analytics workspace, we can send it to a storage account, or we can send it to an event hub. So it's pretty versatile in terms of what we can do with the data once we have collected it. Now, this is kind of what the dashboard looks like that comes from log analytics. So you can see it's a pretty robust dashboard about the metrics of our database and gives us good visibility into what, if we are having problems, where they might lie. And take note that once you get in the demonstration, I've got it set up to send to log analytics. Subsequent configuration of the databases to send there is pretty straightforward and easy. Once you get the log analytics piece stood up and installed, you can easily add additional databases to it. And you would see all the databases into a single dashboard. It's actually a really nice graphical user interface. So now we've kind of talked about 3 different methods on how to find those query performing issues. We talked about query performance insights. We talked about Query Store, and we talked about log analytics for Azure SQL Database, which is still not generally available, but public preview. So now we've kind of got 3 different ideas in terms of how to find those performance issues. Let's go ahead and talk about how we can then take that information and help fix some of our queries. So the first thing I want to talk about are service tiers. So with Azure SQL Database, you've got a couple different options in terms of the level of service you might get with your database. Now keep in mind that with Azure SQL Database, it is platform as a service, meaning that the underlying infrastructure has been abstracted away from the end user or the consumer, such that we can't really tweak the CPU, the virtualization, the operating system, etc. of that specific host. Now we do have the option of picking service tiers that will give us certain levels of performance, such as the number of vCores we get or how much data we're going to consume in storage. But we can't tweak that specific host the database might be sitting on. With service tiers, one of the things I want you to think about when you start to run into performance issue is what region are you in? So if I am in the East Coast of the United States and my database is in Australia, my performance of that database might not be beneficial because there's a good deal of latency between where I am physically sitting and me trying to access the database that is sitting in Australia. I'm going to want to pick and put my SQL database into a region that is closest to my end users or my consumers. If all my consumers are in the East Coast of the United States, it doesn't make sense to put my database in Australia when my users are in the East Coast. It probably won't work for all users worldwide, but if the majority of my consumers are on the East Coast, I'm going to try to solve that 80-20 problem by putting the database in the closest region possible. So keep in mind that when you pick a service tier, that we're also putting the database into the appropriate region. Now, there's 2 kinds of service tiers, a DTU or vCore. Within those 2 service tiers, there's different models of the service tier that you can pick. For example, DTU, which stands for Database Transmission Unit, and that really is a magical formula that wraps up compute and storage and memory and all that. And for a fixed price, you get a certain number of DTUs. Within the DTU service tier, you've got 3 different models, a basic, a standard, and a premium. And so you get varying degrees of DTUs based off what model you are in within that tier. The picture on the screen is actually the example of what the DTU tiers look like. So on the far left in the green, you've got the basic, the purple is the standard, and the blue is the premium. Now, as you go from left to right and scale up from a standard 5 to a P15, which is 4,000 DTUs, your price goes up too. So keep in mind that with the premium level tiers, anytime you put the word premium on something, usually it's more expensive. So in this case, with the DTU, it is. As you scale up, it's going to cost you more because you're in that premium tier. If you are looking to run production workloads in the DTU tier, It's my recommendation that you try to stay within that premium model and not in the standard or basic. Your workloads differ. I don't know your workloads, and your mileage may vary. And certainly a standard tier might work for you. The lower standard and basic tier, you actually get less than 1 vCore. I know the DTU is a compilation or formula that puts it all together. But the basic, and from the S0, S1, and S2, you get less than 1 vCore. So unless your workload is really small, most production workloads are going to need more horsepower than that, than less than 1 vCore. But your mileage may vary, and your workloads may work just fine with that. Make sure you evaluate which one will work better for you. Now the vCore, the vCore comes in the same kind of concept where you've got 3 different models. You've got a general purpose, you have a business critical, and a hyperscale. Now those are all based off explicitly setting the number of vCores that your database wants. So you can go up to 80 vCores in the vCore pricing tier. And so you can specify that you want your database to have a specific and fixed amount of vCores available to it to process your workload. Now we can do things like an elastic pool, which allows us to share resources in a vCore model across multiple databases, and that helps from a costing perspective. But you have that flexibility either in a vCore model or an elastic pool where you can specify where that's going to sit in terms of the resources available to it. One of the things that you need to think about with the tiers is a latency problem as well. With the latency considerations that you need to think about, not only the regions, but this is more about like log IO. If I have a highly transactional workload that's very dependent on having fast as possible log latency or log transactions, meaning I can shove as many transactions through the log file as possible. The higher level tiers, so your premium tiers, your business critical tiers, those tiers are going to have a lower latency in log IO than the lower tiers. So you can run into log IO problems simply by choosing the wrong tier. So if you have an application that requires that higher throughput for the log, you might think about going up into the higher tiers. Again, once you get into the business critical, the premium tiers, those are going to cost you more money because the way that the systems are architected, you get better performance, but you're going to have to pay for it. So just keep that in mind. Another thing to think about with the Azure SQL database and the appropriate tiers, the log file size is dependent on the max data size that you specify for your database. So if I specify a 1 gig database, I believe that my log file size would be about 300 megs, give or take. That's a rough estimate, but that's about right. So if I have a 1 gig database, but my log file is 300 megs, and I have a highly volatile workload that I'm going to throw a lot of transactions through it, data modifications or database changes through it, and those logs, the logged transactions, I potentially could fill up the log file before a log backup happens. That doesn't happen often. I've not really actually seen that happen, but it is possible. So think about in the service tiers, either whatever service tier you pick, if you have a very volatile application or workload, think about expanding the data max size, which would get you a larger log file to allow you to have better throughput and bandwidth of your log traffic. So picking the right service tier can be critical in how your workload performs for your application. The service tier comes also into play with how it's architected. I kind of mentioned that previously. This is an example. What you see before you is the differences between general purpose and business critical of the vCore model. On the left-hand side, we can see the general purpose. The things to note about the general purpose that's really different is that the data and log file are stored on the premium storage, LRS storage, which means that it's network attached to the virtual SQL server that's hosting that database. With business critical, You'll recall that I mentioned that if you go up in the higher tiers, you get better latency overall. That's because if we notice in the left-hand side of that model, we can see that the VM has the data and log file, which are attached locally via SSD to that virtual host where the database is sitting. By using SSD that's locally attached, I naturally get better latency numbers because the disk is right there. It's not network attached where SQL Server has to go across the network. Granted, it's Microsoft's backbone, so it's pretty quick. Most days, even with the premium storage network attached, I still see latencies of less than 10 milliseconds for a read and write to the data files. But if your application really requires really low latency, this is where business critical might come into play simply because of the way that Microsoft has architected the Azure service. So think about the service tiers. You want to think about your log file and how you manage transactions through your log file to help you pick and choose a service tier that is appropriate for your given workloads. So we just recently talked about service tiers. Let's go ahead and talk about the next option that we have to kind of fix things, and that is going to be automatic tuning. So one of the cool things about Azure SQL Database is that by default, the nature of the service kind of helps to merge query analytics and machine learning. So right out of the gate, when we stand up a new Azure SQL Database, I get query analytics and in conjunction with machine learning to get some automatic tuning features. There's basically 3 options that come with the automatic tuning. We can create an index, and keep in mind that the automatic tuning literally is allowing the service to do these options. So we can allow the service to create an index, we can allow the service to drop an index, or we can allow the service to force a last good plan. By default, the only thing that is enabled out of the gate is force last good plan. Now, this option, force last good plan, is also available to you on premises. So you can actually use that on premises. The index operations, the create and delete, is not available to you on premises, in part because we don't have access to the machine learning that we need to be able to make those smart decisions about our workload to see if we actually need to create an index or drop an index or what we need to do. The other cool thing about the automatic tuning is that we can actually do some automated rollback and self-correction. So as the service is using the machine learning to identify and do analysis on your query metrics, if it determines that it needs to do an index or create an index or drop an index, if those operations actually in turn is a detriment to your workloads, the service can identify that and subsequently revert those changes. So if it created a new index, it would drop it. If it dropped an index, then it would actually put the index back in place. Thankfully, with Azure SQL Database, you are effectively running Enterprise Edition of SQL Server. So index operations can be online. So if it had to recreate an index or create an index, it can do so in an online operation, which is the most minimal way of creating an index to help prevent blocking by doing it that way. So thankfully, we can do that. This is kind of what it looks like in the portal. So once we get into the Azure portal, I can show you this. I'll actually run a workload and we'll see if the automatic tuning actually gives us any recommendations. But we can see that we can, one, inherit it. We can either inherit it from the server that the database is sitting on. We can say inherit from the Azure defaults, so that would disregard what the server might have available to specify. Or we can say don't inherit at all. In this case, we can see that my current state, the force plan or the force last good plan is enabled. It's enabled by default. Or in the create and drop index options are off. I do have these set to inherit from the server, but you can certainly go in and change that if you so desire. They're relatively easy to change. And as I said, if you enable the create and drop index feature, the service will hopefully recorrect itself if it does do something that does impose an issue with your workload. So we've already talked about 2 options in terms of how to help fix some performance issues you might experience in your Azure SQL database. We can turn on automatic tuning, or we can look at the service tiers that we've picked to see if we could actually adjust our service tiers to help us get some better performance out of our Azure SQL database. Now, because we're Azure SQL database, not only are we running Enterprise Edition, we actually also get the advantage of running the most latest version, which is SQL Server 2019. So right out of the gate, we get the big, shiny, greatest and newest version of SQL Server. With the release of SQL Server 2019, they rebranded adaptive query processing into intelligent query processing, which are these boxes here that are highlighted. Most of these options are available to you in Azure SQL Database, and you can implement these changes pretty quickly with minimal code enhancements, which makes them a very good solution to help fix some of your query performance problems you might be getting in Azure SQL Database. So let's go ahead and take a look at a couple of these, and I've got demonstrations on how these will work and help you change your workload. So the first one I want to talk about is the table value compilation deferred enhancement that they had released with 2019. If you are familiar with using table variables in your code, you'll know that because there's no statistics on the table variable, every time before SQL Server 2019, anytime that we did a query with a table variable, SQL Server always estimated the number of rows just to be 1, as you can see on the screen before you. Whether you had 1 row or 100,000 rows, it didn't matter. SQL Server always just thought it was 1 row. This means that the statistics about the data contained within the table variable isn't accurate, and you usually probably got bad or poorly performing execution plans. And so with 2019, with things prior to 2019, you got 1 row fixed estimate. And usually if you had a higher number of rows in that table variable, you got a bad execution plan. Temp tables work differently. So this is why this is specifically for table variables, because the temp table we can put indexes and statistics on. So this was explicit to table variables. With the table variable compilation deferred now, the compilation is actually shifted to the first actual execution of the statement. So when the statement actually executes, it doesn't check the table variable until it gets to that point in the code. The compilation frequency remains the same, but now the table variable closer mimics how temporary tables behave. This allows us to get a more accurate row count out of that table variable, which then gives us better accurate statistical information on the data within it. So we actually get a better execution plan with the table value compilation deferred. It is based off the compatibility level with the Azure SQL database, which since it's 2019, SQL Server 2019, the most latest compatibility level is 150. So we need to be at that 150 level when we want to enable this, and then we can actually turn this on and off with a database scoped configuration change. And I'll show you how that kind of works as well when we get into the demonstration. So we can control this on and off. So you want to make sure that you're up at the most recent compatibility level with Azure SQL database. Again, if you stood one up today, that's the level you're going to get, 150. If you've been in Azure SQL database for a while, your database actually might be at a lower compatibility level. You might want to go check and make sure that it's at 150. Another option I wanted to talk about was memory grant feedback. So this was first added back in SQL Server 2017 with the adaptive query processing brand, but it was only available for batch mode. And that was really only available if you were using column store indexes to help take advantage of the memory grant feedback. This doesn't actually change the execution plan, but what it does change is allow SQL Server to do some self-correction on how much memory a query might get. We know that if we don't have enough memory, then the query can actually spill to tempdb, which then goes to disk, which causes issues. So having too much memory, having not enough memory, if we don't have enough memory, then that can cause performance issues. And we don't want performance issues. We want to be able to self-correct and get some other issues fixed. If we have too much memory, if we run a query and it's too much, then that means that we're stealing memory from other queries, and not allowing SQL Server to manage the amount of query available effectively. So a query might be consuming too much memory. And so with memory grant feedback, subsequent executions of the query allow SQL Server to adjust as needed. So if I need more memory than on a subsequent call, I'm going to get more memory from SQL Server. Whereas if I have too much, then SQL Server won't give me as much memory on the subsequent execution of the query. So, and this is just like with the table variable deferred compilation, this is just a simple setting within a database that you can turn on with zero code enhancements and take advantage of it. So this is a quick and easy way to enhance your performance in Azure SQL database. Another option that I consider a performance enhancements, you might disagree with me, and that's totally fine. But with the release of SQL Server 2019, one of the things that came out of that was accelerated database recoveries, or ADR. Now, thankfully, this option is enabled by default when you create an Azure SQL database. And it's one of those cool features that is really impressive. And essentially what they did is they reworked how SQL Server does recovery upon restart, and or if you have to cancel a long-running transaction and have to roll it back. We still have to do our 3 phases. We have to do an analysis, a redo, and an undo. But now it works from a new structure within the data file called an slog. And that slog facilitates us to have a faster rollback. We can now roll back our long-running transactions for almost instantaneously. If you've been a DBA for quite some time, you might have run into a problem where you have a long-running transaction that's been running for 30 minutes, an hour, 12 hours, whatever duration it might be, and then you have to cancel it and roll it back. If you have that experience and you know that rollback in versions prior to 2019, that rollback would take as long as it took you to get to that point where you canceled the operation, and probably a little bit more. So if it was running for 12 hours, you're probably looking at least at 12 hours for it to roll back, because it has to undo all the work it did in that 12 hours. It's probably going to be a little bit more than 12 hours, but you get the concept. With ADR, we can now plan on a much faster recovery time, which means that we can do things in a more with higher performance than we could before. A good example is I actually had to run a query for a client, and it ran for about 30 minutes, and my client had said, "Oh, it's going to be a quick query. Don't worry about it. It's fine." After 30 minutes, I eventually killed the query and rolled it back, and it rolled back in less than a second. So very quickly, it was able to roll back, and I was able to continue on with getting the work done that I needed to get done. I had to rework the query and do some other things. But ADR really helped us to get better throughput with our transactions. It allows us to monitor and manage our transactions with better performance. So I consider this a performance issue enhancement, or a performance enhancement. So thankfully this is enabled already, but just be aware that if you're going to do transactions, explicit transactions within SQL Server, we now have the ability to cancel those and roll those back almost instantaneously. Keep in mind that most of the things I'm talking about today is all based off compatibility levels of the individual databases. Remember, because it's a platform as a service with Azure SQL Database, we don't have access to the underlying SQL Server instance. We are running whatever Microsoft wants to run. So if Microsoft installs a new version, then that's what we're going to run underneath the hood. Microsoft has also changed how they're certifying support for applications and or databases that are now being certified by compatibility level. This ensures that if you are at a certain compatibility level, you'll get the functionality of the SQL Server instance that is certified by that level. So if I'm running at compatibility level 150, that means I'm running basically SQL Server 2019. If I'm running compatibility 140, I'm basically running SQL Server 2017. So make sure that your databases are up to the correct compatibility level. This also allows us to take advantage of the latest fixes that Microsoft releases. So 150 is the gatekeeper, if you will, for like the 2 memory grant feedback and the table variable deferred compilation options that I had talked about, plus a few others. If you're not at 150 yet, try to get there. It's very much like I have a client that is actually, if you had created a database before 2019 had released in Azure, you still might be at 140. Microsoft is not going to increase the version, so they're not going to install a new version and come around and just automatically increase your compatibility level to the new version. So if you've been in Azure for a while, you might want to go look. Your databases still might be at 140. I actually have a client that is still at 140, but it's at 140 for specific reasons. And then eventually we're slowly moving them to 150 to take advantage of some of these new features that came out with SQL Server 2019. Another thing to note about the compatibility levels, while compatibility 150 is equivalent to the SQL Server RTM, if Microsoft has released any subsequent query optimizer hotfixes after the base level of SQL Server 2019, you actually have to enable a database scoped configuration called query optimizer hotfixes. What this does is tells the database to function. Let's say, I think right now at the time of this recording, it's CU8 is the most recent cumulative update from SQL Server 2019, I think if my memory serves. Let's say they released a query optimizer hotfix somewhere between CU1 and CU8. If you set it to database at compatibility level 150 and do not enable the query optimizer hotfix, you are not going to be able to take advantage of the query optimizer hotfixes that they might have released in a subsequent update, cumulative update. If you enable the query optimizer hotfixes, you could then take advantage of any query optimizer hotfix they released in any one of those cumulative updates. So if there is a specific reason that you need to enable that, you can go check out all the cumulative updates. There might be an issue that got fixed with one of those releases. Then you can go enable that with a simple database change. I've actually got a blog post listed right there, that bit.ly link. That'll actually go to my blog, and it'll talk about that hotfix and how it works with both on-premises and in Azure SQL Database. So feel free to check out that blog post and we can see how it functions. All right, so we've talked about a number of different things. We've talked about the service tiers. We've talked about different methods on how to find and identify poorly performing queries in Azure SQL Database. We've talked about query performance insights, query store, and some SQL 2019 enhancements that you can take advantage of to help increase your query performance. Let's go ahead and take a look at a demo, and then we'll come back with a summary and wrap up. Stay tuned. Welcome back, friends. As you can see here, I am in my Azure Portal. I am in my tenant, and what we're looking at right now is a SQL Server instance called SQL DB Demo 2. This is the SQL Server instance I use to do demonstrations with Azure SQL Database. And on this server, I've got a couple databases: AdventureWorks 2017, Demo 1, a SQL Demo 2-East, and a Wide World Importers. These three are all currently paused. They are a serverless Gen 5 1 vCore, but the one that we're going to work with today is the AdventureWorks 2017. You'll notice that it is online. It is a general purpose, so think about what we talked about earlier in terms of service tiers. My database MDF and log files are all on a network blob storage within the Azure ecosystem, so it's network attached storage basically. And I've got 4 vCores that are assigned to this database. You might be asking real quick about what the serverless is. You can specify that when the you can specify that when the database is not being actively used, you can actually disconnect it basically from the compute node behind the scenes and not be charged for CPU. You can't have any active workloads or connections to the database for it to pause, but that can help save you money if you're looking to save some cost on your Azure SQL database, if your workload facilitates that type of disconnection and pausing. Just note that if you go to serverless, when you spin the database back up and when it gets reattached to that compute node, there's a spin up time that might be detrimental to your workload, so just make sure you test it. Now, the other thing I've got going right now, just so that you can see it. Here's a Powershell script that will generate a workload against that specific database. We can see that I've got the SQL DB Demo 2 database endpoint right here, and I've got my AdventureWorks database. I'm going to run a number of jobs through that database just to generate some workload. So I'm going to go ahead and get this going. I'm going to type in my super secret passwords. And we can see that it's gone ahead and started to create the workload that we want for this particular database. And essentially what this is, the workload is nothing but a random set of select statements. The PowerShell will actually go through that random list, that list of select statements, and randomly pick out which ones it wants, and then basically repeat the process and just continue to run those select statements against the database. Now keep in mind that I'm running this from my local laptop here in Louisville, Kentucky. My database is in the East region. So if we actually go into that database, we're back in the portal. We can see that I briefly did run some workloads, so we can actually very quickly and see what our utilization is just by going into it. This isn't Query Performance Insights. This is not Query Store. This is just me browsing out to the database to see what it might be doing in terms of compute utilization. We can see that it's gone up a little bit, so we can see that, and then we can react accordingly if we wanted to. And as it refreshes, we should start to see some of the workloads actually appear in here as compute, and we can go from there. So one of the other things that I didn't really mention in the slide deck is that when we log into the Azure Portal, one of the really cool things is that we can actually take metrics like this and actually create a dashboard for our database. So when I log into my portal, I can look and see very quickly whether or not I might be having issues, because it'll show up right here on the dashboard. And so we can actually utilize that to help further identify whether or not we're having. And you can see here that this dashboard is max CPU, max data IO, and max log IO percentage. And so if we had an issue, then if we had 100% CPU, then we could identify that pretty quickly just by logging in, by the sheer nature of logging into the portal. So if we go back to our database, so here we can see some workload being generated. Right here we can get some good compute utilization going, so we can see that we've got that workload generated. If we scroll down in the left-hand side of the blade, we can actually go look at the Query Performance Insights. We can see the Query Performance Insights option right here. Looking at the Query Performance Insights, we can see that we've already got some metrics being gathered. And remember that the Query Performance Insights is built in by default with the service. So if you create a new Azure SQL database, you're going to get this functionality out of the gate, price included in the price. So get familiar with this portal, and so you can see where things are happening. We can see that based off my workload, we've got a couple different things happening here. Each individual color here located on the right indicates a specific query. So if we can actually scroll down a little bit, we can actually correlate this CPU time with the yellow query down here and actually drill into that query and actually get the query text so we can see what it's executing. We can see some metrics about the overall query. Now keep in mind that I just started this workload, so I don't have a ton of metric information, but you can kind of get the idea as to what you can see within this tool. And it'll actually break down some metrics for you based off hour-long aggregations throughout the day. So we can see that I've actually got more metrics down here, in part because I just started that workload. We can furthermore, if we scroll up, we actually see this recommendations options. We can actually see if there are any recommendations for this particular query. Now in this case, I don't have any recommendations, so none are shown. But if the service thought that it might be, there might be some recommendations, then you would see that listed here. And you could automate those recommendations, or discard the recommendations and then go back and actually look at which ones you've discarded. Let's go back to the database itself. This is Query Performance Insights still. Again, we can look at the long-running queries. We can actually do some custom sorting based off CPU, data I/O, log I/O duration, that type of stuff over a period of time to help us identify what issues we might be having with our queries. So that's Query Performance Insights. The other thing that we talked about, and remember that Query Performance Insights is based off Query Store. So this data that is displaying here in this nice, neat format is also available to us in Query Store. And we'll go take a look at that in a second. Log Analytics is another thing that we talked about in terms of a tool that's available to you directly from within the portal. You might not have noticed when we looked at the dashboard actually had a log analytic workspace for us. If we click into that, I've placed it there on the dashboard for easy access. So that way I can quickly drive into that log analytic space and see what kind of performance we're having. So if we come down here to the general section and look at workspace summary, we get placed into a new blade, and we've got some options here. You can use this log analytics for a couple different SQL related things, namely what we're looking for is the Azure SQL database. We can click on the Azure SQL database. And here we can see these metrics kind of look like one. We got our database here. So this is the server that we are looking for. If we click on that server, we can actually drill in a little bit further. Now, because the workload just started, I don't have a ton of metrics, as I said, but you can kind of get the idea as to what might be contained in here. But if we back out a step and go back, so that is the server. This is back. So let's say we can drive into one of these metrics. And so now we can actually get more information on our subscription servers and databases that we might want to use to further enhance the performance of our databases. Another beauty about using log analytics, and remember this is a public preview. Microsoft reserves the rights to change the preview, so don't hold me to it, but assuming that it goes to general availability, I love this feature in terms of the richness of the data that is displayed. The other thing I like is that if your database, hopefully it doesn't ever happen, but if it gets accidentally deleted, which means that, one, you could always restore it, but if it got deleted and maybe you missed that for some strange reason, the log analytics is outside of the SQL Server, meaning that the data that is contained within the log analytics would still be there. So it would be persisted even if the database got corrupted or something happened for some strange reason. That data is still there that you can utilize to do query performance analysis and help fix your query performance. So log analytics, pretty easy to set up if you go back to the database. Let's go back to the database. If we scroll down to the diagnostic settings, now keep in mind that I have already previously set up the log analytics workspace. You'd have to do that prior to actually assigning it, but you essentially have to set up the log analytics workspace. You come into the database, you have to specify that workspace to send the metrics to, and you actually have to install the log analytics for SQL database solution in order to get it all connected and get together. Make sure you go out to Microsoft.com and look at the documentation. The documentation is pretty straightforward on how to set it up, but a great way to get insight to what your database might be doing. Another thing we talked about within the portal is automatic tuning. So because we're already right here, if we look at the automatic tuning feature option for the database, we can see here, this just looks like what I showed you in the slide deck, is that force plan, create index, or drop index. Now in this case, it's set to on. I've set it to on for this particular database, so we can go see if we have any performance recommendations from the automatic tuning to see what it might want to do. And so if we, and it's easy to change, you can just click on the individual options to change the desired state. And we'll go ahead and turn that on, so it is on. We're going to apply it. So now if we come over to performance recommendations, we don't have any. Sometimes it works, sometimes it doesn't. Sometimes with this demonstration, I can get a recommendation to come up. In this case, I don't. If I did have one come up, this is the same performance recommendation that you saw in the Query Performance Insights screen. We could then apply that recommendation or discard it if we so desire. But automatic tuning, it's that simple to turn on and off. So if you think that will be a benefit to your workloads, make sure you go and turn that on so you can take advantage of it. Those are a couple of ways within the Azure Portal that we can find query performance issues. Let's go take a look at Management Studio really quick. So this is SQL Server Management Studio version 18.7, which I believe is the latest. I think at the time of this recording, it's the latest one. We can see on the left-hand side that I am attached and connected to my SQL DB Demo 2, and I have my appropriate databases here. So I'm working with the AdventureWorks 2017 database. I just checked the workload and it is still going, so we still have traffic going to that particular database. So Query Store, if we expand the database, you'll see this Query Store option. And then here are all the options that we have within Query Store to help us identify performance issues. As I said with the slides, I almost always start with the top resource consuming queries. And here we get a very nice visual, just like I showed you in the slide deck, of what Query Store has to offer. So in the bottom, we can see our execution plan. We can see that's kind of a gnarly looking plan just at the offset. And we can see kind of where this query lies in terms of durations with an overall total. Another option that I use quite often is CPU time to see if I have a higher CPU consuming query. I can use this particular metric to help identify it. And then if I were to have a separate plan, I can actually come in here and force a good known execution plan if I desire. I can manually enable that forced plan just with a simple click of the button and help me identify and correct potential query performance issues. This is a great resource to use. If you're not familiar with Query Store, I highly recommend you get familiar with it. Check out Erin Stellato in the SQL community. She's the go-to person for Query Store information. Check out her stuff. But the Query Store is a great resource to find those query problems and then help fix them. So those are the three ways that we can help find those queries: log analytics, Query Performance Insights, and then Query Store. So let's go take a look at some of the 2019 features that are available with Azure SQL Database, and in particular the two that we talked about, the table variable compilation and then the memory grant feedback, so we can see that in action and see what happens. In this demo, we're actually going to switch over and use the Wide World Importers database. So we're going to flip over, and because it's serverless, it might take a second for it to come online. But basically what we're going to do is create or alter a store procedure. That store procedure should already be there. But that procedure is going to utilize a table variable. And then we're going to set the compatibility level of the database, something not 150. I think the query will either set it to 130 or 140. We will run the store procedure with the compatibility level set lower, and then we'll check out the execution plan and see that the table variable does have an estimated row count of 1, and then we'll go ahead and flip the database to a compatibility level of 150, and then run it again. And then when we run it again, we can go check the query plan to make sure that it has a better estimate of the number of rows in that table variable. That'll help us get a better query plan out of the database. So that database finally came back online. We're going to make sure that we're set in the right context. All right, right context. I'm going ahead and create or alter the store procedure. And we can see that I create the table variable right here in the middle, and then I'm going to insert some lines and then do a select from it, and we'll get the estimated row count as 1. So we'll go ahead and run that and make sure it runs. I'm going to pull some pages into cache just to make sure the cache is warmed up. I want to make sure that the database is set to the compatibility level of 130, which is 2016, SQL Server 2016. And then after I set the compatibility level, I will set the statistics time and I/O on so we can get some metrics back. So let's go ahead and take a look at that. So here it's running the execution or the store procedure. So we should get some information back. So we did get rows back. Let's go ahead and take a look at our metrics. And the one thing I forgot to do is turn on the actual execution plan. So let's go ahead and run that again. Apologize for that. So in that runtime, let's take a look. So the total runtime was 1.2 seconds or 1200 milliseconds. So remember that number, 1.2 seconds. Let's go ahead and take a look at the execution plan. Our table variable is right over here. We can see that with the table variable right here. So if we hover over our clustered index scan, if I can get this to work, there we go. We can see here that I have an estimated number of rows is equal to 1. We can see that right there in the hover point or mouse over of that operator of that table scan, or clustered index scan. And now we're going to actually set the compatibility level of the database to 150 and run it again with the same thing. So we're going to see the execution plan. We take a look at our run times. Look at that. So if you remember the first time that we ran this, it was 1.2 seconds, whereas with compatibility level 150, we're now down below, just below 500 milliseconds or half a second. Now that might not sound like a lot, but if you extrapolate this out to multiple executions of this store procedure, what if we were running this multiple times a second? That additional 700 milliseconds would add up over time and you'd get better performance. That's the only thing we changed was the compatibility level. Now, if we go back to the execution plan and look at this clustered index scan, we can see right away that our estimated number of rows went from 1 to 228,000. So SQL Server now has a much better idea as to how much data it's playing with and can make a better decision in terms of the execution plan. That's why that works. We can also go see if we wanted to. If we look at the database scoped configurations of the database, if we scroll down right here, we can see that the deferred compilation for table variables is enabled. So it is also a database scoped configuration that we can turn on and off if we so desire. I'm not sure why you would turn it off. I think it's a great feature. Hopefully you saw pretty easily just by enabling it how much better performance we can get out of our queries. So let's go take a look at the next demo, which is memory grant feedback. Again, keep in mind that this is it's all baked in with Azure SQL Database because it's running SQL Server 2019. So with this, we're also going to use wide world importers. We're going to go ahead and clear the procedure cache because I just created the procedure in the other one. We're going to make sure that everything's nice and clean. We're going to go ahead and set the compatibility back from 150 to 140 so we can mess around with showing you the improvements of the memory grant feedback. We're going to just double check to make sure that it's enabled. And it looks like both the batch mode and the row mode is enabled. Keep in mind that the batch mode was column store index with 2017. The row mode memory grant feedback is the new one that we are really cared about because I'm not always going to use a column store index on every single table. So we're going to look at the execution plan of this select query out of wide world importers. I'm going to turn on the actual execution plan and we'll actually go look at it in the XML as well. But we're going to run this. Shouldn't take too long to execute. Looks like it's done. It came back with 3 seconds and 231,000 rows. 231,412 rows to be exact. But if we look at the execution plan, looks pretty benign. We don't have anything going. Keep in mind that the compatibility of the database is set to 140. So we're running basically SQL Server 2016. So the memory grant feedback doesn't really show up here. What I want you to look at is this memory grant line within the execution plan. This is the XML version. This is execution plans are actually built off of the XML. So the XML actually gives us quite a bit of information, but we can see here the required memory, the desired memory, the requested memory. So it gave us quite a bit of memory, it looks like. 2.3 megs, maybe gigs. I'm not sure if that's gigs or megs. How much it was granted, what the wait time was, the max memory used, etc. So a wealth of information about the memory grant. But let's go back to the query. And let's up the compatibility level to 150 and then run it again. Same query, just we're going to change the compatibility level. So, yep, 231,412, so the numbers match. And now if we look at the execution plan, one thing you'll notice different is this warning sign on the select operator. We can actually see down below where it says warnings, the query memory grant detected excessive grant. The grant size was 341 megs, but we only used 5 megs of that. So SQL Server said, I'm going to give you a bunch of memory, but in reality, you didn't use it. So that is going to cause a problem with other queries because we've now robbed them of the memory that they might need. Now, if we look at the XML, so if we look at the XML, one, you'll see that the structure has shifted just a little bit, but if we still look at this memory grant info line, this one right here, if we scroll over to the right, we still get our granted memory, max use, max, blah, 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 the wait time, the requested, all that type of stuff. What's interesting is this very last option. Whoops. Is memory grant feedback adjusted? And the answer is no, because we are executing this query for the first time under the new compatibility level. SQL Server doesn't have anything to base a decision off of. So it tells us we're not going to adjust anything because this is the first time that we've run this query. So let's go back and run the query again. And let's see what happens. Close out of this. So if we run this query again, and we'll notice that our warning on the select operator went away. We no longer have a memory grant issue that SQL Server has identified. So let's go ahead and take a look at the execution plan. So looking at the plan's XML, the line that we want to look at is this memory grant info line. This is what we looked at last time with the last execution of this query. If we scroll over all the way to the right again, we will notice a new option, is memory grant feedback adjusted? In this case, our response is yes, we're going to adjust it. If you remember from the first time execution, SQL Server said, nope, we're not doing anything because we don't have enough information. Now on it, we're doing a subsequent execution of the query. SQL Server can evaluate what was given before and now adjust appropriately so that the query gets a better memory grant, which helps further prevent memory starvation with other queries, as well as prevent maybe underutilizing or granting not enough memory for this particular query. So we can actually go back to the query and close out of this, find the query. We can actually hover over the select, and we can see that the memory grant here was about 7.5 megs. That's pretty significantly different than what the first execution was, which was 300 megs if I recall correctly. So this is a great way to ensure that SQL Server makes a good decision about doing memory grants for your queries. Again, remember, this is just set with a compatibility level change and ensuring that the database scoped configuration is enabled. But this is something that you can enable or ensure that is enabled on your Azure SQL database to enhance your performance. So now we've already seen these two options, the row mode memory grant feedback and the table variable deferred compilation. Hopefully you can see quite easily how it can help improve your performance with absolutely zero code change. Let's go ahead and jump back to the slides and we'll do a summary and then we'll go ahead and wrap up. So welcome back, friends. We just got done looking at the Azure Portal, some tools within the portal to help us identify and locate query performance issues that you might be having. We then looked at SQL Server Management Studio, look at the query store, some of the cool features and abilities that it offers, as well as we took a look at a couple of the things that came out with SQL Server 2019 that will help us to get better performance out of our queries in Azure SQL Database. So I leave you with this. Keep in mind that Azure SQL Database is just SQL. So if you're a DBA that's familiar with on-premises SQL, a lot of your information and knowledge that you have about how SQL works on premises will translate to Azure SQL Database, whether it's Azure SQL Database or Azure SQL Managed Instances. It's just SQL underneath the hood. Make sure you know where to find the issues for your database. Anytime you do a migration especially from on-premises to the cloud, performance always isn't an apple-to-apples comparison. So you make sure you do your due diligence when you do a migration and you're suddenly in the cloud. But make sure you know where to find issues for your given workloads, whether that's query performance insights, whether you prefer to use query store or log analytics or some other methodology. Just make sure you know what works best for your workload and your environment. Make sure you examine the right service tiers for your workloads. If you have a service tier, you put the database into a lower service tier, your performance might suffer and you might see degradation in your query performance. Now, thankfully, with Azure SQL Database, it's pretty easy to scale up to a different tier, and that's usually a click or two of a mouse button. You have a brief outage when it fails over between compute nodes. But scaling makes it, especially in Azure SQL, scaling is a super easy process to help facilitate you getting into the right tiers. Make sure you evaluate your automatic tuning options. It can be a great solution to automatically enhance the performance of your queries by creating and dropping indexes. If you've got indexes that are duplicate or whatnot, the service can drop them and or create indexes to help facilitate your workload. So make sure you look at turning those options on and make sure that they work for your given workload. Finally, take a look at the zero code change enhancements that you could implement from a database perspective to boost your performance very quickly. I showed you the table value deferred compilation, as well as the row mode memory grant feedback. Those options are baked into the product right out of the gate. They don't cost you anything extra. And you saw how easy it was to enable it with zero code change. I didn't change anything in any application to take advantage of those two options. There are others with the intelligent query processing platform that got released in 2019. Make sure to go read about those and see if those will help you as well. I just talked about two of them here. There are others that might help you even if you've got specific areas in your queries that you want to try to fix. That is ways to optimize your performance with Azure SQL Database. I appreciate you being here and watching this recording. My name is John Morehouse. Make sure to check out my blog. If you have any feedback about my session, I would love to hear it. Even if it is negative feedback, I'm a big boy and I can take the feedback. Tell me how I can improve and make this a better presentation for future attendees. Please make sure to enjoy the rest of the Data Platform Summit 2020. I've seen the schedule and it's chock full of absolute goodness. And don't forget that I will be around for live chatting Q&A. So thank you much. Stay safe. And hopefully eventually we'll be able to have a conference in person. Thank you much.